All right, should we keep going? So just want to make sure if you, all these ones are good to do with the calculator, you know, all the ugly ones that are bigger and stuff. So again, if you don't have a calculator, well, if you have one, you know, just any calculator is fine. Doesn't matter which one. Anyone's fine. If you don't have one, borrow one from a friend. You can use them on the test. I'd encourage you to bring your calculators to class with you, because you know that way you can make sure you don't want to like show up on the test day all of a sudden with a new calculator you're not used to using, right? Bring one to class. Make sure you can do these. Anyway, if you're gonna buy one, let me write down what I said. The Casio Natural Display is a very, very nice one. So if you're gonna buy one and you don't have one, Casio Natural Display, bookstore, Walmart, Target, all those places, is a very, very easy to use one. People really like it. All right, so this question then, we know it's multiplication. Well, it's got parentheses. Things are right up against the parentheses, right? So we're multiplying those numbers together. I would figure out the sign myself ahead of time. I wouldn't put the sign into my calculator. I would just multiply the numbers quickly on my calculator. You can if you want to. But can you tell me what is the sign going to be? I mean, is it going to be positive or negative in the end? Yeah, you just count the negative signs, huh? How many negative signs does it have up there? 2 minus signs, right? 2 minus signs. 2 minus signs. It's going to be positive. Remember, 2 negatives makes positive. 1 negative is just negative. So there's a negative there, and there's a negative there, huh? 2 negative signs, going to be positive something. And then I would just take my calculator and go 10 times 5 times 8. Just 10 times 5 times 8. Hit the buttons. What's that, 400? It's 400. Positive 400, or just regular 400. And we're done. Is that good on that? You could have done that one by hand. You know, like 5 times 8 is 40, right? 5 times 8 is 40, and then multiply by 10, it just throws another 0 in the back, huh? So that one we could have done by hand. Good? All right, stop. Okay, so -5, -3, -4. Let's figure out the sign of the answer ahead of time. Is the answer going to be positive or negative on that one? Negative. Going to be negative, because 3 negatives makes negative, huh? So notice if there's an even amount, like, because every 2, like these 2 negatives make positive, but then one more negative changes it back to negative, huh? Every 2 negatives make positive, one more it's back to negative. So it's going to be negative something. It's going to be negative, and then just use your calculator. 5 times 3 times 4, what's that, 60? Negative 60. Good on that? All right, so especially with the calculator, these are super easy. All right, there we go. So try that one. Use your calculator. Figure out the sign ahead of time. If it's going to be positive or negative on that.
Even in these, when you add in numbers, it's going to be the parentheses around it.
What's that? They're good? Yeah, just multiply. You can just multiply those on that one. So yeah, so this one, how many negative signs do we have? 3. We have 3. Yeah, 3 negatives. So the answer is going to be negative in the end, isn't it? 3 negative signs. The answer is going to be negative, right? So if you have an even amount, 2 or 4 or 6, that'll be positive, because every 2 make back to positive. So if you have an odd amount, the answer will be negative. So multiply, then just multiply the calculator. 7 times 6 times 4 times 3, I don't know. 504. Thank you. 504. Oh, negative, huh? We already said it was negative. Negative 504. Anybody do that in their head? I couldn't do it in my head. because I'm not a human calculator. Do you guys know who the fastest human calculator in the world is?
You,
Yeah, no. I saw the person in person about 11 or 12 years ago at a math conference in Monterey. The math conference in Monterey, beautiful big giant hotel there in Monterey. It was a certain math conference. Like 300 of us math teachers from all around came there, and what's funny about it was featured on the brochure. Speaking at this math conference will be the fastest human calculator in the world, like Guinness Book World Record holder person. You know, like this is a world famous person. Like the number one in the entire world, right, will be at this conference speaking at this math conference. I'm like, wow, okay, that's kind of cool. So, but they showed no picture and gave no description at all. I didn't know man, woman, boy, girl, what country, anything, right? So what was so funny to me about the whole experience was my stereotypes. I just imagine, I don't know what you imagine, this person is still the fastest human. Last time I checked on Google, you can check right now on Google if you want to, type in fastest human calculator in the world. This person is still it. Last time I checked, a couple years ago. Anyway, was I expected, that big stage open, and out was going to come the fastest in the world record holder. I expected some 14-year-old, skinny little Indian or Asian boy or girl to come out and go, hello, I'm the fastest human calculator in the world. That's just what I expected, right? It was my stereotype, I guess, right? Well, the curtains open, and out popped this 35-year-old white guy. What could be my neighbor, right? Just sweats, Mr. Casual, kind of Mr. Cool, just bouncing around. Hey, guys. I'm thinking, what, you? You're the fastest in the world? You could be my neighbor out mowing the lawn. You? And he is. Yeah, is it?
is that him?
Yeah, that's him. He's 50s now. Yeah, he's a white guy. Yeah, he's American. He's just an American. He's faster than, it was funny to me.
What are you
Yeah.
talking about?
Well, he just showed that he could, he raced a graphing calculator on the big screen. So that the salesmen, they're trying to sell us the big fancy TI calculators, they were at the conference, they wanted to sell us all those. Anyway, so they put their TIs on the big screen in the conference room, and he said, all right, somebody from the crowd picking out all of us math teachers, he's like, and so somebody pick a three-digit number, somebody go, okay, 576, and he'd say, great. I'll start at 576. Somebody else pick another one. 319. Okay, great. And he would add 576 plus 319 in his head. Now, you could probably do that once. I'll do it by hand here. 895. So he would go, okay, 576 plus 319. He'd go 895. And then he would add it again. He would add 319 again. What would that be? 1, 10, 11, 12, 14. He would add 319 again. 12, 14. Then he would add 319 again. And he started going faster and faster with 3, 1. So he'd go, he'd start with the 576, he'd add 319, he'd go 895, he'd add it again, 12, 14, 15, 30, and then he started going faster and faster. And fast as that guy could push those buttons for the TI calculator, he'd go 15, 33, and he was just adding 319 that fast. As fast as the guy could push the buttons on the screen, he was whipping them. As fast as he could say them, he could add 319, just repeatedly like that. Super fast. He could multiply them. It was amazing. He said, when I try to say the wrong number, I can't say it. It blocks. That must be nice, huh? I can say the wrong number. Yeah, he said he noticed it in 3rd or 4th grade, that he could just do them in his head super fast. Yeah, it was phenomenal. It was miraculous what he could do. I mean, he's still the top in the world. He said he doesn't memorize them. He goes to competitions, and the people that try to compete with him, they memorize a bunch of things. He doesn't memorize. He's actually calculating the numbers right then. He's just got something. He doesn't even have a college degree. That was why he doesn't look like an academic, and that's what's funny. He just looks like regular old guy, and he is, but he can do these calculations.
Has he already signed away his brain to?
Oh, the science? I wonder.
Die?
I did. You could read all. I'm sure Google has all kinds of things to say about it. Yeah, it's interesting. I didn't think about that. Yeah. All right. Well, anyway, there we go. So if you're that, then you can do this in your head. Otherwise, like me, use a calculator. All right, minus 504. It's a weird, it's not like a smart thing. It's like a weird little rule, really. If you've seen it, you know it. If you haven't, then I'm here to tell you. It's a really weird little rule. What would you think the answer to that should be?
Positive?
81.
It seems like it should be positive. because negative times negative is positive. The weird trick is that doesn't actually mean two negatives. It only means one. Why? Well, there's a difference. It's a weird trick, so you do have to remember it. It's kind of a weird little trick. This would be two negatives, and so yeah, positive 81. That would be. But this one up here, let me just change the color for emphasis. But this one here is only one minus sign with two nines, so it's negative. Why? If there's not parentheses, then the 2 is only on the 9. There's not two minuses. If there's parentheses, it's 2 of the whole thing, including two minuses, so it's plus.
So
Let
only
me-
one has the parentheses.
Say that again?
Yeah, so let me say that again several times, much more slowly. So you see, so basically, let me say it this way. A 2 power, or really any power, is going to make you repeat, right? We all know that. But the question is, what is going to be repeated? The whole minus 9? Or just the 9? How do we know? Well, basically, a power is a repeat symbol. And you only repeat the number that it's immediately not on, the one it's right on, not even the sign in the front, unless parentheses extend its influence. Does that make sense? It's like, who do you have jurisdiction over? This power only affects the 9, not even the minus sign, which is weird. You think, well, it's a minus 9. You know what it is? It's one of those invisible ones. It's like there's an invisible 1 there in the front. That's kind of like what it is. A minus sign really means a separate minus 1. So if there's no parentheses, that minus 1 is not repeated twice, just the 9. So the answer comes out negative in the end because there's really only one minus sign. But if you put parentheses, that's clear. That's clear, right? The 2 is on everything, right? The whole thing, this is all under its influence, so the whole thing is repeated, 2 minuses plus. So that's a weird trick. Yeah.
That's because the first example would give you a negative answer, but then every even number would give you a positive one if that rule didn't apply. So in other words,
Right.
every
If that rule didn't apply, every even one would be
even exponent, so you get a different, you'd have a negative and then the next.
would be positive, and then yep, that's right. So that's what would be true for the Princey case. Yeah, you're saying what's true for the Princey, yeah, right? Because if I put like an odd power on here, on the Princey, that would be a negative answer now, huh? Because that'd be an odd amount of minus signs. If it went to the 4th power, then it would be back to a positive. Yeah, but none of that applies for this case because that minus is like, you're not talking to me. I'm not under your jurisdiction, right? Does that make sense? You know how you can think about it? Well, I just think it's like when you're watching soccer. I watch a lot of soccer these days. That little 10-year-old girl I almost forgot in the car, she's now a little soccer player. And so we watch a lot of, I'm watching soccer this weekend. But the coaches, they're in real serious travel soccer. They're all serious. They get real serious about all that. I think it's so funny. Like 2 years ago, she was 7, and they were talking to all the parents about scholarships. I'm thinking, she's 7. I mean, come on, just let them play the game, you know. But the coaches are real serious, and they're like, parents, no comments from the sidelines. We've given exact instructions to these kids. We have them. They're real serious about the whole thing. So anyway, so I'm not on the field. I'm not listening to the coach. That's my analogy, right? This is the coach. He's telling people what to do, but he's only talking to the people under his power. In the parentheses, right? He's only talking to this stuff. He's not talking to me. When he says run faster, Abigail, my daughter, he's not talking to me. I'm just watching. I'm just a spectator, right? So that little minus on the outside is not affected. It's not listening to the coach. It's not in the game. It's not on the parentheses, right? So if that helps. So only the things in the parentheses are affected. All right. So remember that. It's a tricky little rule, and it'll come up a lot. In a lot of plug-in situations, it'll come up. So you got to be aware of it.
It will be just the same way. Minus 9
Yes.
times positive 9 times positive 9.
Correct. Yeah. So if we had like negative 9 to the 3rd, again, that minus sign is not on the field. He's not listening to the coach. He's like, I'm just sitting on the sidelines watching this happen. And the 9s are going, we're listening. Just 3 regular 9s, 1 minus in the front. Because he's not listening to the coach. He's not in the game. It's just a sideline sitting. Yep. Good? So it'd be negative, yeah. All right. So So minus 2 squared. So try that one. So is that minus in the game?
Yes.
He's going to obey the coach, right? Or he'll be sitting the bench. So that one. So is that minus going to be repeated? Yeah. The coach is saying, "I want 2 of you," and that minus has to obey. He's not just a spectator on the side. He's in the game. He's in the parentheses, right? Repeated twice. 2 negatives. Positive or just regular 4. Good. So if it's in the game, if it's in the parentheses, it's got to do what the coach says. If it's outside the game, it's just a spectator. Okay. Try that one. Okay, so is that minus sign on the 6? Here, let me make it a little bigger. Is that minus sign in the game? It's going to obey the coach. It's going to be repeated. So you're going to have minus 6, and then 2, 2, 2. Huh? And so what's the sign in? Is it going to be positive or negative answer in the end? Going to be positive because we have 2 minus signs. Huh? 2 minus signs going to be plus. All right, and then just hit the buttons on your calculator. 36, 72, 4. What is it? 288? 288? Thank you. 280. The human calculator could do that really fast, I'm sure. 288. There we go. Questions on that? That good?
He does everything, the human calculator, like,
I don't know. I just saw him for that one
or just math?
half an hour. He does multiplying and dividing and things like that. And he's not Indian or Asian. That was the shocking part for me. All right. So 7y, y equals negative. So they want you to see what the word there. We're back to the words evaluate. See how they say evaluate? That means they want a value, huh? They want a number in the end. So go ahead. They want you to plug in, right? Whenever they say evaluate, they want you to plug in. So take that y equals negative 11 and plug it in. Get the answer on that. So what do we always have to do? How about this? Would this be correct like that? 7 minus 11, negative 4. That's wrong, huh? What am I doing wrong there when I do it like that? Parenthesis. Yeah, remember whenever we plug into a formula, we must use parentheses around the number we plug in. So I've got to put parentheses around this and plug in like that. And now, what does that change? Now it's multiply. It's not add or subtract, huh? See the difference? So you want to remember parentheses. And really, that's true to the original meaning, huh? In the beginning, what was between the 7 and the y in the very beginning? What's in the middle of them? Yeah, nothing, which means times, huh? So it was times all along. We can't be suddenly changing that to subtraction or something, right? It had to be times all along. It was 7 times y. So whatever y is, it's got to multiply that, doesn't it? So that's why we put, you see why now we put parentheses around things we plug into formulas? That keeps us true to the original meaning, doesn't it? The original meaning was times, and if I didn't put the parentheses, it would suddenly become subtract. That's changing the meaning. The parentheses keep me true to the meaning. So it's multiply. Is it going to be positive or negative? Only one negative sign, huh? So it's going to be negative 77. Good on that? Good. All right. Okay. Okay, so a squared b cubed. A is negative 2. So we're going to plug in two things. So go ahead and plug both those in. It's evaluate again, which means, plug in, get a value. Plug both those in, parentheses around them. Word problem things here. Okay, so try that one. They want you to write out in math what they're saying in words. Go ahead, give that a try.
I added.
Yeah, I forgot to change.
Cabrera, C-A-B-R-E-R. Rachel.
R-A-C-H-E-L. You were able to put an ad card in or online or whatever?
Oh, yeah, I had went down that, yeah.
Okay.
It went.
Good, good.
Thank you.
All right, so the product of negative 4 and 8. Yeah, so let's go through some of these words. What does product mean? Yeah, do you know that? That's correct. Product means multiply. So the product of negative 4 and 8, that means negative 4 and 8 multiplied. Good so far. Increased by 4. How do you do increased by 4? What do you think that is? Add, subtract, multiply, or divide? Increased plus 4. So there's what they want. There's what they're saying. We have to figure it out also, but it's going to be like two parts where part A, they want you to actually just like write it out. And then part B, they want you to figure it out. They want both on this one. So is that good so far? See how they're saying that? Yeah.
I didn't put a parentheses around negative 4. Is that wrong?
No, it's totally fine. Yeah, let me write that way too. Either way is totally good. If you wrote it that way, it still means, was it 8? Yeah, it still means multiply. So yeah, as long as you can write it several different ways, as long as it means multiply, it's all good. So it does mean product, multiply, and then add. So it's good. Is that good? And then part B, or second part, they want me to figure out what that is. What is that? Minus 32 plus 4. Then you can just calculate if you want to. It's minus 28. Right, if you lose $32 and you gain back 4, you're down 28. Which is much more than 0.99 cents. Since that's less than a penny. Good on that? That makes sense? Let's go back and enter that answer in. Well, it'll make a new one is what it'll do. If you got that down on the 2-2. Okay. Try that one. Write an expression for the following phrase and evaluate. So it's like the two parts again. So write it first and then find the value afterwards. Evaluate. Twice the product of 4 and negative 3 added to the product of negative 8 and 5.
First part be exponents?
What's that?
Would the first part be a exponent?
No powers on this one. Yeah, the twice. What does the twice mean? What do we do with twice? Yeah, multiply by 2, yeah, in the front there, yeah. Or the back, either way. So twice a product. So 2 times something, right? Because twice, it's 2 times. Twice what? Twice a product. What does product mean? Multiply. So 2 times 4 times minus 3, huh? Good so far? Added to. Plus. Good. Added to what? Product of negative 8 and 5. You can put parentheses around both those, or just, you do it like this, or whatever. Either way, it's fine. Does that make sense? Now we got to figure it out. We got to get the value, but that's the first answer they want, is just it written out. And then the second answer, they want the value, which is calculated. Is that good so far? Like that. And then we calculate it. These 3 are going to multiply, get an answer separately. Those 2 multiply, get an answer separately, then add them up. Right? Makes sense on that? Remember, adding's last. Remember the order of operations? Main thing to remember is adding, subtracting's last. So do the multiplying first. So 2 times 4 is 8 times 3. So it'd be negative 24 for the first answer. Is that good so far? And it was negative, right? Everybody see that it was negative? Because it had 1 minus sign. Now this guy has 1 minus sign also. So it too will be negative 40. Right? Combine them.
Could I represent it in a different way?
How so?
For the first section, I put 2 outside and then made a larger parentheses with
Oh yeah.
times negative 3 in there.
Yeah, that's totally fine. Yeah, that's totally good. Final answer, minus 64, right? Because they add together. Like you lose $24 and you lose $40, you lost a lot of dollars. Yeah. Yeah, you could put the 2 back here. You could put a big old parenthesis around those 2. Yeah, all kinds of ways. Math Excel is usually pretty user friendly. It knows those other versions are the same. Yeah.
So in this case, the plus and the minus won't affect each other then?
This plus and this
No,
minus, you mean?
The bottom one.
This plus and this minus?
Yes.
Okay, gotcha. Yeah. Well, let me answer it this way. It's the same as if you just said this. Those are the same. How do I know? Well, what's a plus and a minus make? Minus. So it's really just minus in the end. So yes, you're right. It doesn't affect it.
So,
It's really just minus in the end.
so since you come out with 2 minus at the end, it will be a positive.
No, they're not multiplied.
Yes.
So many rules, huh? So many rules. Yeah. Good. Everybody see that, right? Yeah, because you would say, well, these 2 minus should be plus, but these aren't times. They're adding, subtracting. Yeah, you always got to keep the adding, subtracting rules separate from the multiplying rules because there's always different rules on that. Yeah, so it's going to be negative 64 either way. So both those versions are right. Both are okay on that. Good. Getting all those little bitty. Math is a language, isn't it? Lots of little rules of the language. It's the language of science, is what they say, right? Math is used to describe things that are real, right? All right, so there we go. So, good. All right. Yes. There's a good question. Okay. In fact, actually, before we do that, let me make an easier question. How about this? I don't know if you've seen this before. What is 2 to the 4th times 2 to the 3rd? Let me give some multiple choice options.
2 to the power of 7.
All right, let's do multiple choice as a class, huh? So take a look up there for a minute. 2 to the 4th times 2 to the 3rd. That dot in the middle means times, right? 2 to the 4th times 2 to the 3rd. Here's our question. Which one? This will be like what multiple choice question. Think, and I know you've all seen some of these rules before, huh? You've done some of this stuff before. But but I imagine you might be a little fuzzy on some of the particulars. I mean, that's what we're trying to do, is I'm taking what you know and just honing it, making sure it's exactly right. So think for a second what the answer is, and then I'm just going to take a survey. We'll just see how many people answer which different answers. All right, how many people think answer A? 4 to the 12? Nobody likes A? One, okay. How many like B? A couple like B, 5, 6, 7. How many like C? 3 or 4, like that. So far, B is most popular. D, how many like D? Then D is about tied with B, and then none. How many say it's not really up there? None of those answers, no. Okay, so B and D are the most popular, it seems like. B and D. Okay. Anybody from the B or the D camp want to give a reason why your answer is right?
Don't you, when you multiply, don't you just add the exponents?
Just add in, like, you don't multiply the 2 times 2, you mean?
Yeah. So just add the, keep the.
Well, I hear what you're saying. You know, you're talking to me about rules that math teachers say and math books say, and that's good, and that's good. I would even prefer, and it would stick with you better if you talk to me about what things really are. Remember, math. Who's on the throne of math? Truth. So I know some math teacher might have said some rule, and hopefully they told you the true rules, and hopefully I'll tell you the true rules. But in the end, think about what's true. Think about what's true up there. That may be true. Something else may be true. What's true? What I mean is, I think you can do it. You're maybe just not doing it. What does 2 to the 4th mean? I mean, what does it truly mean? What have we agreed little numbers in the upper right-hand corner mean? Yeah, totally, right? You all know that. I'm not telling you something you don't already know. You already knew that. And what does the other one, the 2 to the 3rd, mean? Well, the 3 of them. Yeah, and they're what? In the middle. Timesed. So what does it mean? Right? You guys are right. The D answer is right. The rule was right. But seeing it that way, I think it'll stick with you, and you'll never be fooled if you realize what it really is. That's why they made that rule. You're told. It's kind of weird, huh? It's kind of weird you don't actually multiply these 2's together to get 4. It's kind of weird. You think, well, it's times. Yeah, but this is what's true. This is my final answer, isn't it? I mean, what does 2 to the 4th mean? And what does 2 to the 3rd mean? So what do you got? 7 4's? No. 7 2's. Right? Why don't we multiply the powers? Because it's not true. Huh. That's always the bottom line in math. What's true? This is what's true, isn't it? So you have to remember. So then the true rule is when you're multiplying same bases, right? Those are the same bases, the 2 and the 2. You add the powers, don't you? You add the powers and don't multiply the bases because it's not true. Make sense? You don't actually multiply the 2 times 2 on the bases. You just leave the 2 and add the powers. And we can see right there, that's the truth. It's 4 2's and 3 2's. It's 7 2's. It's not 7 4's. Huh? Make sense? The more you can do that for yourself in math, get back to what's true, you'll remember the rules. Let me just say it clearly. There's too many stinking rules in math to memorize them all perfectly all the time. There are. I did not do math, not only me. Nobody does well in math just by memorizing rules. That's part of the deal. Sure, you got to do that, a little bit, but there's just too many to keep them straight all the time. What's better is to get to the truth, to think what's true. The more you do that, you'll be able to come up with the rules, because you're going to forget some rules on the test. You're just gonna. There's just too many. Unless you're doing this for a living like I am and teaching it every day, you're not going to remember all the rules perfectly. So going back to think what's true? What does this really mean? That'll help you. That way you don't have to have a perfect memory. If you had to have a perfect memory, I never would have made it through math.
When we get to keep a scratch paper and stuff too?
Yeah. Oh, yeah. You get a 3x5 card. How did I mention that?
That's our scratch paper?
That's your scratch paper. Yeah, 3x5 card. Anything you want, front and back of a 3x5 card for a Thursday's test. So yeah, you could write one of these rules or problem examples or whatever you want. Yeah, that's your scratch paper. 3x5 card. Anything you want, both sides on there. Yeah, because I'm not a big memory guy. I mean, I don't have a terrible memory. And my wife and kids always kid me. My wife we've been married 25, I'm losing track, 25, 26 years. A long time, you start losing track. Anyway, my wife will remember way back when. She'll go, remember when we went on that trip and we had lunch at that place? And she'll remember what we talked about. I'm like, honey, I always kid her. I always say, it's like you're already a widow. Your memories are your own. I don't even remember the trip. I just give her a hard time. But my kids and my wife all kid me. I have a terrible memory. I never could have made it through math if you had to have a good memory. It's not about memorizing as much as it's about getting the logic, getting the reasons on things. So this was all wrong. I shouldn't leave false things on the screen. Okay, let's try that one. So it's 9 to the third times 9 to the 6th. Try that one. Don't say it out loud. Give everybody a chance to try it on their own papers there. So don't think about rules as much as think about what does that mean? What does 9 to the third really mean? And what does 9 to the 6th really mean? Imagine them written out and then think, okay, so what do we have all together? So this means 3 9s, and this means 6 9s, and so what do we got all together? 9 9s, huh? Yeah, it's not 81 to the 9th, is it? It's 9 9s. 6 9s and 3 9s is 9 9s, huh? And that's all they want is the answer like that. They don't even want you to calculate what that is. They just want you to leave it 9 to the 9th. It's some gigantic. They say type exponential notation, so the power notation. They want an exponent power answer like that. Good on that? That makes sense? All right, try that one. Y to the 5th, y to the 7th, y to the 5th. Think about what those really are. Put them together. So what does y to the 5th mean? Yeah, 5 of them, huh? And what does y to the 7th mean? Well, you get it. It's a bunch of y's, isn't it? So how many y's altogether? 17. Just add them up. There's 17 y's altogether, huh? See how the math rules flow naturally if you know what the things really are. Good? All right. This is our last section that'll be on the test Thursday. All right, let's try this one. So 3x to the 7th times 8x to the 6th. So we're multiplying those together, right? Parentheses times, we're multiplying those. So here's what I would suggest. You know if they just had a 3 and they just had an 8. Forget about the x's for a minute. Let's just suppose they just had the 3 and the 8. You know about that. That's just multiplication. 3 times 8 is 24. Yeah, if you're rusty, just use your calculator. If you're rusty on some of those times tables, yeah. So that part, so the numbers in the front, just multiply those like you would a 3 and an 8 at any time. Now, so that's the 3 and the 8. What do I do with the x's? Well, you know what x to the 7th means. 3, 4, 5, 6, 7. And you know what x to the 6th means. 3, 4, 5, 6. So what do we have all together?
13x.
There's our answer. So you see what we did? So the numbers in the front, so the rule is, if you want a rule, because rules are helpful too at the same time. So step 1, you multiply the numbers in the front, because those are just normal numbers, and you add, step 2, add the powers, don't you? Multiply numbers in the front, add the powers.
So in other words, if I plugged in a value for x on the first equation and then I plugged it in on the answer equation, it would be the same result.
Exactly, well said. Yeah, because this expression and that expression are two ways of saying the same exact thing. You're exactly right. They're the same toaster, so to speak. plug into them, they'll give you the same result. Yep. Is that good?
The last section that's gonna be on the test.
Yeah, so we've actually, when we finish the section, we will have covered everything on Thursday's test.
Tomorrow we wouldn't-
We'll just take tomorrow off. No, I'm kidding. We only have 20 days total, 19 days total. We can't take it. We're gonna move ahead to new stuff that'll be on exam 2. Yeah. Good on that. So multiplied numbers in the front, add powers. All right, so we're multiplying together. So try that one. So you know what to do, right? Multiply the numbers in the front, add the powers. So, multiply numbers in the front. Add powers. So the numbers in the front, -3 times -3. Positive or regular 9, because 2 negatives make positive, right? And then add the power. So 9 and 4, 13. We add them. And we're done. Does that make sense on that? Multiply numbers in front, add powers. A to the third, B to the fifth, times A to the seventh, B to the sixth. Try that one. If you're at all confused, think about what those really are.
And it would be time, right?
The parentheses mean those guys are multiplying. Mm-hmm. Yeah. All right, so those two powers, well, yeah, suppose you're looking at this and you're thinking, I don't remember, well, what is A to the third, AAA? What is A to the seventh, 4, 5, 6, 7 A's? So what do we have there all together? 10 A's. So we add the powers, don't we? Even though the overall things are multiplying, we know that means you add the powers because that's what you really have there is 3 A's and 7 A's. You get 10 A's, and we got 11 B's. And we're done. You don't need the parentheses anymore. You know, just like that. Does that make sense on that? What if somebody said, well, you add them together. It's AB to the 21 like that. You just add those two. We know that's not right because what does AB to the 21 mean? What is it really? Yeah, well, actually, without the parentheses like that, that would only mean 21 B's. The A is not even in the game. He's a spectator watching the sidelines, not obeying the coach, right? That'd be 21 B's. That'd be really crazy. See how you know a million rules right away by knowing what things really are. That can't be right. It's this, huh? All right. So 20 u to the 9th n to the 8th times minus 3 u to the 10th n to the 10th. All right, try that one. Okay, so what's the rule here? We multiply, yeah, numbers in the front, and you add powers, right? So we're going to multiply 20 times negative 3, right? So that's what? Minus 6, because positive times negative is negative. Okay, now we're going to add powers on the same letters. So u to the 9th and u to the 10th, u to the 19th, and n to the 8th, n to the 10th, n to the 18th. And there we go. Multiply numbers in front, add powers. Is that good on that? Questions?
And we're supposed to do it, no, we're supposed to just write the equation.
Yeah, that's it right there. There's nothing more to plug in on that one because they didn't give us any more information on that. Let me let you try, without me telling you the official rule, see if you can just figure that out. It's 2m to the 6th. So give it a try. Think about what that really is. And see if you can come up with the shortcut answer. So what do y'all think? What is that 6 power making it do?
Multiply 2 6 times.
Yeah, doesn't it mean 2m, 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 right? 6 of them?
Mhm.
We all agree that's what a 6 power means on anything it's on, right? So now, I can rearrange the order. Do you realize that? Like, think about 2 times 3. Is that any different than 3 times 2? It's 6 either way you do it, huh? So when you have a bunch, what if I had 2 times 3 times 4? Could I rearrange that 3 times 2 times 4? Absolutely. When you have a bunch of things multiplied, you can shuffle the order in which they're multiplied because it makes no difference, huh? So likewise, I can reorder the order in which all these guys are multiplied, and I can put all the 2's together first and all the m's at the back. That's the same thing, huh? As long as there's 6 2's and there's 6 m's all multiplied together, it doesn't matter what the order is. Does that make sense? And so then, now this, your calculator, 2 times 2 times 2 times 2, was it 64? 64. And what is all those m's multiplied together? There's the answer, huh? Does that make sense? Just by going by what it really is. Now, we could, having done that longhand, let's just come up with a quick shortcut rule that would be nice also. You can take this power and you can just put it there and put it there. It's just 2 to the 6th, m to the 6th, and then just use your calculator. What is 2 to the 6th? 64. That would be the shortcut, the quick way. That's the same as the long way, but quicker. Does that make sense on that? So when we have powers outside parentheses, it's going to come in and be the power for both the things inside the parentheses, right? Does that make sense? So we can write that rule, because rules are helpful too. So the rule is powers outside parentheses multiply powers inside parentheses. You get what I'm saying there? So powers outside multiply powers inside. Now you might, if I was you, I'd be thinking, what do you mean multiply, Mr. It didn't multiply. It didn't. It wasn't 2 times. I didn't go 2 times 6, and that's 12. I didn't multiply. Why am I saying multiply? Well,
Multiply is power.
the power, exactly. What power does the 2? It doesn't multiply the 2 itself. It multiplies the 2's power. What power does he have? Invisible 1. Invisible. Remember, if they have no power, they really have an invisible 1. So 6 times 1 and 6 times 1 made those 6's. That's what it is. It's powers multiply powers, like that. I should say powers outside parentheses multiply powers inside parentheses. Yeah. So let's try another one of those. Okay, so minus 5a all to the 3rd power.
Oh, you just said it was supposed to be Y, so everything.
Yeah, it's all good. Okay, so powers outside parenthesis multiply powers inside. So there's a 1 power, what, right? Invisible 1 powers, right? Everybody has a power. All the numbers, all the letters, they all have a power. And the power outside multiplies the powers inside. So what do you got? 5 to the 3rd, a to the 3rd, and the negative is what? How do we know it's negative or positive? How do you know? It's 3 of them, isn't it? Right? You know, if you were to write it all out, we don't want to do this every time, but it's good to just kind of picture it in your mind. it means minus 5a, minus 5a, minus 5a. 3 of them, doesn't it? So how many minuses do we have? 3 minus sign. So it's minus 125 a to the third. Because it's 5 times 5 times 5. A times A times A. Does that make sense on that? Questions I can answer? So the powers outside parentheses multiply the powers inside. 5 to the third and A to the third. Okay. Okay, so we have d to the 6th to the 10th. D to the 6th, all to the 10th. So see what you can do there. In fact, let me give you 2 questions at the same time. Like, what? Yeah, I like that. There we go. Yeah, try A and B. They're different. Similar, but different. And the best thing to do is to think what they really are, instead of rules. I mean, rules, okay, but they can confuse you. Just think, what does that really mean? Just be real. Be real about what those things really are.
They all move the mind.
Just think about powers and what they say, you know. Powers mean repeat, right? Powers mean repeat. Okay, so, for example, what does this one really mean? I mean, I know there's a rule and everything, but just to make sure we're clear, doesn't this mean d to the 6th, d to the 6th, d to the 6th, d to the 6th, 10 times?
Yes.
Because there's a 10 on something. When 10 is on something, when the power of 10 is on something, it means 10 of those. It means 10 d to the 6s, doesn't it? And each of these is 6 d's, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, etc. So that's 6 d's, 6 d's, 6 d's, 6 d's, 6 d's, 6 d's, 10 different times. Right? Isn't that what it means? So how many d's we got there? That's got to be d to the 60th. The quicker rule is just powers outside multiply powers inside, and you can skip all that. But I want to make sure we're clear that rule is true. It comes from just looking at what it really is, right? Now, how about this one? A lot of people look at that one and they go, oh yeah, same thing, you just multiply those d to the 60. No. No. That can happen easily if all you're doing is memorizing rules and you're not thinking, what is that really? What is the first thing really? Well, it's 6 d's. What is the second thing really? 10 d's, 5, 6, 7, 8, 9, 10. So what do we have there? 60 d's? No. 16. So here we add. Here we multiply. Now I can help you with a rule also. I want to give you both. You know, a rule and a reality. But reality is always better than rules. The rule is this is a power outside parentheses, multiplying powers inside, right? Whereas the other one, these powers are not outside, right? They're not outside. That's why they don't multiply. So that's the official rule, if that helps, right? The official rule is powers that are outside, like that 10. He's outside the parenthesis, so he will multiply. Whereas the 6 and the 10 over here are both insiders. Nobody's outside the parenthesis, so they don't multiply. They just add. But again, that'll only go so far. I mean, final at the end in 4 weeks, you might not remember, though. There'll be so many rules in your head by then, It's easy to forget rules. It's easy to be fooled with rules. But you should learn rules, because when you know them, they are quick, But also have as a safety net underneath you as you walk the tightrope of a math test. Have underneath you something that will keep you from dying if you fall off the rule. And that is reality. Always be able to go back to reality. If you're taking a test, a final exam for this class in 3 weeks from Friday, it's that quick. 3 weeks and 3 days from now, we'll be taking the final exam on 5 units of math material. Anyway, you might look at a question like that in the final and go, oh, now what was that rule? That was way back in the first week. That was 27 million hours of math ago. There's something about parentheses, and hey, it's got parentheses. Parentheses mean multiply. I'll just multiply those. D to the 60th. Hopefully, you're falling at that point. You've slipped off the rope, on the tightrope. You are falling. The whole question is, will there be a net to save you from death on that problem? The net is reality. Will you stop and go, wait a minute. That's 6 D's and 10 D's. That's not 60 D's. No, hold on. Let me look at this again. Oh, yeah, that's just 16 D's. And you don't die. But those who just go by rules, and there's no reality happening for them, when they slip off the rope, they die. We all slip off the rope, right? Nobody's got a perfect memory. You're all going to slip off the rope. You're going to forget some rules. But the question is, are you going to fall to your death on that problem? Or are you going to be caught by reality? Try to be real. Try to be real. Just always keep in the back of your mind, what is that really? Oh, it's 6 D's and 10 D's. Oh, yeah. That's the atom rule. I remember now, All right. Is that good? So see, there's the 2 rules, and then there's reality. Powers outside multiply powers inside. And these guys are both insiders, so they add. Okay, so many rules already, and we're only 2 days in. All right, so 2 to the 4th to the 2nd. So power outside parentheses, what does it do? Multiplies the power inside. So it's 2 to the 8th, and you can just stop right there. How do I know? Do they want an X number? Well, they say type in exponential notation. So they want you just to leave it this way. Sometimes they want you to leave it. Sometimes they want you to just multiply it on your calculator. You guys know how to use the power button on your calculator? It's so some calculators have an X to the Y button. 2x to the y, 8, hit equals. Some calculators have like an up arrow button, depends on the calculator. 2 to the 8th power. The answer should be 512, is that what it is? No. 256? 256? 200. Anyway, they don't want the 250. They actually just want 2 to the 8th. But sometimes they do want you to multiply it out. I just want to make sure you can do that in your calculator if you need to. Oh, it lets you do the whole thing? Great. Okay. They'll take it either way. Yeah, so just make sure if you have trouble with that, grab me after class. I'll be glad to help you with the calculator on how to get the power stuff happening. Just take 10 seconds and you'll be rolling on that. Okay. So 7u to the, what is that, 6th? My eyes are getting old. 7u to the 9th. Okay. Yeah. So try that.
What's with the point in between?
Oh, that's just multiply?
right?
Yeah. It's not really needed, huh? Because we already have the parentheses, so it's extra. Yeah, doesn't really do anything. Yeah. Just extra emphasis. So multiply those however you see fit there. Okay, so the official rule is powers outside parentheses multiply powers inside, huh? What powers are inside on the 7 and the U? Both 1 powers, huh? Remember, everybody has a power. If they're not showing their power, it's an invisible 1 power. So that 6 is going to multiply and multiply. So 7 to the 6th, U to the 6th, and here 1 power, multiply, multiply. 7 to the 9th, U to the 9th. So far, so good. Powers outside parentheses, multiplying powers inside. Now, we can shuffle the order, right? You can put the U's next to each other and the 7's next to each other. You can always trade the order of things multiplied. Doesn't matter. Now, what can we do with these 2 7's and what can we do with these 2 U's? With their powers, I mean. We add them, right? Because this means 6 7's and 9 7's. So that's what, 15 7's? And this is 6 and 9, 15 U's, huh?
That one's confusing me right now.
Yeah, that one's a little tricky, huh? Yeah, so let's go through it one more time. Yeah.
Can you just read 7U with 15?
Good question. Let me ask everybody this question. And you mean like with parentheses?
Yes.
Are those the same thing? Think about reality. Don't think about rules. Well, you can think about rules if you want to, but just reality.
Yes.
Yes.
Yeah, those are the same, aren't they? See how you know? Because this is obviously 15 7's and 15 U's. What is this? 15 7 U's. 7 U, 7 U, 7 U, 15 times. That's 15 7's and 15 U's, just all rearranged, huh? Yeah, those are 2 ways to say the same thing, aren't they? So that'll really help you. Say on a multiple choice test, like Thursday, if you have this answer on your paper, and option B is this, grab it. You know that's the same as your answer, huh? Grab that.
Does it make a difference with the brackets,
Parentheses?
parentheses, yeah.
Yeah, well, these are actually the same thing. Yeah, these parentheses are saying 15 of the 7 U's. So that means 7U, 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 15 times. And no, the fact that they have parentheses doesn't matter. You can take them off and rearrange all the 7's and all these, and end up having 15 7's and 15 U's, and it's the same as that. 15 7's, 15 U's. Yeah, so the parentheses don't matter. To give a long answer to your question,
So
they don't matter.
We can write 7U with the exponent of 15 without parentheses.
Good question. Let's answer that question.
That's what-
Could you write it like that? Is that the same thing?
No.
No,
What does that mean?
you,
Altogether.
Is 7 in the game?
No.
Or is he just watching? He's just watching. The 15 coach said, I want 15 of those. Give me 15 push-ups, right? But he's not. But the parent on the sideline, I'm not doing 15. I'm too old for push-ups, right? I'm just watching my child do the thing, right? That's a sideline watcher. He's not. So it's just 15. This means 1 7, 15 U's. So is that the same? Not the same, huh? So that would be. So don't grab that. They'll try to fool you with that on the multiple choice test. I do say these things. Oh, it's you, Mr. You're trying. I'm just grabbing these tests off the book publisher's website thing, and I just will say, I'll just tell it to Cal, say, give me one exponent problem, give me one of these type, and then it just makes the test for me, and I hand it to you. So they make up the options, and they try to fool you with things like that. So they're testing if you really know the rules. So that's different, huh? You would not grab that option. That's different than these guys. These guys are the same as each other, because in both these cases, there's 15 7's and 15 U's, aren't there? But here, there's only 1 7. 15 U's. That's different. Different animal altogether, right? Good question. Is that making sense? That's how I learned math too. I asked my teachers millions of questions. When I did my homework, I would have a list of paper. Why is number 3 doing this? And why, I would have questions. I think my teachers were scared to see me coming in the halls. I would come up, so why, Mr. Jones, why does 3 do this and why? And they would explain to me, and my understanding would fill in. I'd be like, oh, yeah, that's right, because of the powers and the da-da-da. I mean, that's what it takes. Bunch of rules, bunch of little things. That's what it takes. Good. All right. So, but, a lot of talk. The quick way is the rule. Power outside, multiply powers inside, and then just put them together. Okay, try that one. X to the 4th, y to the 3rd, all to the 6th. See what you can do. All right, so what does that power outside the parentheses do? Yeah, powers outside parentheses multiply powers inside, huh? So that'd be 4 times 6. So I'll just write that again. Power out. Guess I don't need a number 1. Powers outside parentheses multiply powers inside. So 4 times 6 is 24. 3 times 6 is 18. And there we go. Powers outside, multiply powers inside. And we're done. That's all we need to do on that one. Does that make sense?
So you're multiplying 4 times 6?
Yeah, 6 times 4 and 6 times 3
Oh.
on that. Yeah, both of them. So that power multiplies both of them.
Okay.
Is that good? That makes sense. So powers outside, multiply powers inside. And if there's no power showing, it's a visible 1, right? It's always an invisible 1. All right, try this one. 7c to the 15, d to the 20, all to the 3rd. Powers outside, multiply powers inside.
We got the parentheses,
What's that?
parentheses.
The final answer doesn't require parentheses. Yeah, you can get rid of them. Yeah, remember, whenever something from the outside goes in, you can drop them. So we can drop, once that 3 goes in, we can drop them. Okay, so that power on the outside, what does he do? Write it again for you. Yeah, powers outside parentheses multiply powers inside parentheses, right? Now, so that 3, now here's the mistake I often see on this kind of a question. They'll go boom and boom, and that's true, that part's good. So 7, what is that, 45 and 60?
Yeah.
But there's a mistake there. That's not the whole answer. There's a mistake there. I often see this as given the answer. What's wrong with that?
7?
Yeah, what does the 7 need?
45.
Yeah, remember what's the rule here? Powers outside multiplied powers inside. Now, the other mistake, sometimes people go 7 times 3 is 21. That's not right either, because the 3 won't multiply the 7. The 7's not a power, right? See, powers. Powers interact with powers, not with bases, right? That 3 is not going to multiply the 7. It'll multiply the 7's power. Well, what is the 7's power? Invisible 1, right? Remember, everybody has a power, even numbers, letters. Everybody has a power. Invisible 1, so it's 7 to the 3rd. That's correct now. Does that make sense?
Would you, figure out 7?
Yeah, I don't know. Sometimes they do, sometimes they don't. On a test, it'd just be multiple choice. You would just look down and see what they have. What would that be if we did it?
343.
343, okay, yeah. So either one is really right. Whoop, 45, huh? Both these are both good. Either one. Either one could be on the multiple choice test we take on Thursday. They could have either option. So just look at them, see which one it is. Use your calculator. If they have 7 to the 3rd, or if they have 343 on that. Yeah.
So 7 and C work together?
They are together, but they're not. That 15 power does not apply to the 7, right? Because there's not parentheses here saying 15 is over both these guys. 15 is only over the C. He's not over the 7. Yeah, good question. Yeah, does that make sense? 15's only the C's power. He's not the 7's power on that. Good. All right. They're getting messier.
Number 17 is bigger than that.
17 to Bowman. All right, we got one more to go for that. All right, let's see here. So this is 3 to the 3rd, B to the 3rd, to the 2nd, 3 to the 4th, B to the 3rd, to the 3rd. All right, try that one. You know the rule. Powers outside, multiply powers inside, right? Okay, so powers outside multiply powers inside, right? That's the first step. So do that first off. So this 2 power will multiply, so we get 3 to the 6th, B to the 6th, and 3 to the 12th, B to the 9th. Good so far? And you don't need the parentheses anymore. How do I know I can take them off? Something from the outside went in. Remember with the floodgate thing, whenever a power, a number in the front, whatever, something from the outside of the parenthesis goes in, drop them, right? So the parentheses are gone because the power from the outside went in. Powers outside parentheses, multiply powers inside. So far so good. Now, what do we do from here? We can rearrange things, right? Remember the order, these are just a bunch of things multiplied, right? Doesn't matter what order you can put you don't have to, but if it helps you, you can switch the order and put the B's next to each other and the 3's next to each other. And then what can I do with these guys now? Do I multiply the 6 and the 12 or add the 6 and the 12? You add them, right? So that would be 3 to the 18th. Those powers add. Even though it's times here, right? Same bases multiplied, powers add. What? Because we know that's what it really means. This means 6 threes. This means 12 threes. We got 18 threes, huh? That's what it really means. Always go to reality. That's the best thing. And then b to the, what is that, 15? Add those.
No,
No?
no, what I'm saying is, what happened, because you actually multiplying 3 times 3 also.
3. Where's that? Oh, right here? This 3 times 3?
No, the whole, equation.
Oh, like this 3 to make it 9?
Yes,
No, that's not right. Remember we talked about that? So, I know there's so many rules, huh? 3 to the 12, 3 to the 6. What does it really mean? It means 6 threes and 12 threes. I can't write 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So altogether it's 18 threes, not 18 nines. So remember, when you multiply bases, you don't really multiply the bases. You just add the powers.
They're the same base, right?
You keep the base the same, exactly.
But if the base, only if the base.
Only if the bases are the same, well said. Yeah, so if this was like a 2 to the 12th, and you couldn't do it at all. That's right, that's right. Yeah, no, good question. I know these rules, there's so many, huh? That's why I'm always bringing you back to reality, because the rules will fail you, because there's just too many of them, right? Your mind isn't perfect, and you're going to forget some of the rules. But go back to reality. 6 threes, 12 threes, what do you got? 18 threes, not 18 nines, huh? 18 threes, that's reality. So you don't actually multiply the bases. When the bases are the same, you leave them, and you just add the powers. Yeah, but here, I've got another one. You can tell by my tone I'm going to give another false rule. But I've seen people do this one a lot. 2 to the, I don't know, let's make up 4th or whatever. And people go, oh, yeah. You just go 3 times 2 is 6, and you add the powers. 6 to the 10th. That can't be right. Just, right, think about reality. What does this mean? 6 threes. What does this mean? 4 twos. What is this? 10 sixes? How could that be the same? That's not the same. So you can't do that. Right? So like you were saying, the bases have to be the same, or you can't do anything. Right? The bases have to be the same, and then when they are, you leave the same base. 3 stays 3. You don't actually multiply the bases. You leave the same base and add the powers, because that's reality. 6 threes and 12 threes is 18 threes. Yeah.
Do a similar one like this again?
Yeah, we can do another one. I've heard 17's all that and more. Is that good on that one? To there. Everybody see what happened there? So we'll maybe recap one more time. So from the beginning, I took the power outside parentheses, multiplied the powers inside. Power outside, multiplied the powers inside. And then I just combined the 2 threes. 3 to the 6, 3 to the 12, add them up. 3 to the 18th. You don't multiply the bases. You just add the powers. And b to the 6th, b to the 9th, you just add the powers. B to the 15th. Like that. 17 is combining, multiply. You know why 17 is hard? Because it's doing what an exam does. So I've had a lot of students over the years, and they tell me, Mr. Heron, I could do all that homework, and then the exam was harder. Well, the exam is the same as homework. It's just all mixed up. So here we have power multiplying rules mixed in with adding, subtracting rules. So that's like a test. The rules are mixed in. That makes it harder. So give it a try. We've done all these rules, but we haven't mixed them like this. What do powers outside parentheses do? Multiply powers inside. So that 2 has an invisible 1 power on him. Don't forget. And so that 2 power from the outside will multiply the powers inside, including the 1 power, the invisible 1 power on the 2. Right? So this will become 2 squared, a to the 4th, b to the 6th. For the first part, so far so good. Powers outside multiplied powers inside, right? Good so far. Now, what do you do for these guys over here? They're multiplying, right? And what are the rules we've learned for multiplying? So here I'll write the power thing in. Powers outside multiply powers inside. Over here, it's numbers in front multiply powers add, right? Remember that? So the numbers in front multiply. So we'll go -4 times +6. -24. Powers add. What do you mean? A to the 1, invisible 1, right? And a to the 3? A to the 4. Because there's no powers outside parentheses there in those two. I'm not multiplying. I'm adding powers, right? B to the 5, B to the invisible 1. B to the 6, right? The 5 and the 1 make 6. Good so far? Everybody good with what happened there? Powers. Multiply the numbers in the front. I'm sorry, there was no, yeah, you multiply the numbers in the front, add powers. Right? Okay, now.
Would you solve for?
Yeah, what is 2 squared? 4. So let's make this 4. A to the 4th, b to the 6th, plus -24. Whoops, a to the 4th. B to the 6th. Now, can I do, now these are being added. Right, but, so when you add letter expressions, so now you got to keep all these different rules straight. This is, like I said, this is like what a test is like. This is why you really have to practice for a test, because you can know one rule all by itself in one day of homework, but putting them all together is another story. So do you remember, what are the rules for adding, subtracting letter things? Like how do you do 7x squared minus 3x squared, or plus? Let's do 7 plus 3. What's the deal there? Well, how do you do that?
Only the numbers.
Only the numbers, and you don't. Do I make it x to the 4th? No. X squared. You keep the powers unchanged. Remember, that's like terms. You only mess with powers when you're multiplying things. But if you add or subtract things, you keep the powers unchanged. It's like terms now, is what it is. 4 minus 24 is minus 20. And you keep the powers the same as they were. There's our answer. Minus 20, a to the 4th, b. Well, I'm kind of scribbling here, put it over here. Minus 20, a to the 4th, b to the 6th. Right? I did 4 plus -24. Does that make sense? It was adding, subtracting at the end there. It was like terms. See how that's a little more tricky? Keeping all the rules straight together. That's called examination preparation, right? That's what you need to do to get ready for a math test. Shall we do one more? And we will have finished one. Did I flash too fast off that last one? Everybody got that copy down? Is that good? All right. Let's try this one. Oh, Roberto is here. Roberto, I'll let you say, this is Roberto, I'll say a few words and I'll let you say a few words. I've already mentioned him.
Okay.
He is, Roberto, you want to write up your hours?
Yeah, I'll do that while you're talking.
Okay, great. Yeah, so Roberto's going to be our, well, you're not really even ETC, right? I heard are they not doing ETC
It's
or
still
something?
called ETC, I think.
Do they? All right, whatever.
Give it a label.
Whatever you want to call it. Roberto doesn't care what you call him. But he is our official class tutor, which means he's better than a regular tutor because he won't show you different ways. That's kind of sometimes what can mess you up, huh? When you go for tutoring and they like show you a different way and you're like, I'm more confused than if I'd ever gone now. That won't happen with Roberto. He's always dialing in with me. He's sat in my classes before. He knows the methods I use. He'll show you the same ways that I show you. So he'll be a good person to go to. He'll have the practice exams. He can I'll email them to him and he'll have them to help you get ready for the exams. So he's putting his hours up there. Yeah, so if you want to go to lunch and then Roberto will be, no, that's in the tutoring center.
Yeah,
Where
so,
the LI 134?
LI 134, there you go.
Yeah. So you guys know where the library building is, right? Where it says Media Center. You know that section that says Media Center over that part of the library? If you go right in those sliding doors and go straight, the computer lab's on the left, but you go straight ahead, that's the tutoring center. That's where Roberto will be at those hours, and they have computers in there. So even if you don't have a computer, they have laptops and desktops. You can just go in there, check out it. You got to give them your student ID, check out a computer. Just do your homework right there. That'd be a fabulous place just to do your homework. And if you need any help, you just grab Roberto, or some other tutor if Roberto's busy, and they'll help you with that question, and then you can just move on and get through your homework.
Yeah, there you go, I think.
Yeah. Good. That's perfect. 12 to 2, 12 to 2 every day.
Thursday, an extra hour for some reason.
Excellent. Yeah, it's perfect. So, anything else I'm not remembering?
Not really. I think. I guess what you can expect is, depending on the amount of people that show up, I can either do more individual tutoring or more group tutoring, depending on the amount of people. You will need to know your student ID when you go in. Sometimes students act surprised because they ask you for that to sign in to the tutorial center. In order to check out a laptop, you need to, like you mentioned, a government ID. And they also have other tutors there, just in case maybe you're not comfortable, talking to me, or you don't want to. Either way, they have different tutors there that can.
We all want to talk to you, Roberto.
Well, people have different methods of learning, right? Maybe some people are more credit for or something.
Right.
They also have different tutors, so I definitely recommend you take advantage to go there. Way better, I think, than to help me solve this button on the problems.
Right.
And really, I think it's more time efficient, right? You get stuck on a problem, or maybe you need to understand a concept. You don't have to scrabble through so many notes or try and find the answer. You can ask the tutor, get an answer within usually 10 minutes. And it's usually empty during summer, so it's probably a better time. Because there's more tutors available, basically.
Yeah.
Do you guys have any questions for me that I can maybe you would answer? Yeah, go for it.
I won't get an appointment.
No, you can just show up. I'll be there during these hours. The tutorial center is there. I want to say till 2 or 3 they're open. And then they open around 9. That's when they have tutors in general and drop-in area, but I will be there during these hours specifically. If there's any kind of changes to time, you can always talk to me and I can bring it up to the supervisor and see what they think about it, since they're kind of flexible around summer, but just kind of talk to me before, talk to Aaron before.
In the event, let's say I want some one-on-one time, can I make an appointment for one-on-one?
That one, with me personally, you would, I'm not too sure if you can do that since the school is paying for it. It might be just kind of like, I don't know, something to do with intents. But you can probably bring it up to the front desk of the tutorial center and they might be able to help you find tutors. It's going through their system and they might be able to post it up there. This person's looking for one-on-one time. Although I'm not sure that would cost you to actually have the one-on-one with the tutor.
Yeah, they're not generally, I mean, I know some people prefer that, and that'd be great. They're not generally set up for that. They're just generally there to, serve a lot of people. But like you said, summer it's a little more empty. You might have just a good shot of just going in there, and there will be some one-on-one time. But they can't, as far as I know, they can't, guarantee that or promise that unless you want to hire one of those. You can hire those tutors to be your own private tutor somewhere else in the library when they're done with their hours at whatever their pay rate is. But as far as the tutoring center, it's just general help. But yeah, you probably get a lot of individual attention in the summer. Yeah.
And these hours were effective yesterday. I should have been here, but I was getting my schedule updated. So today I'll be there, and Thursday and Wednesday, etc. I'll be in there. You can just ask for me, Roberto, or say ETC for Aaron. I'll probably know front desk.
Yeah.
Any other questions?
Send me an email, Roberto, I'll ship you the practice exams, and we'll have all that. Good, good. Okay.
All right. I'm gonna go get
Thank you.
my car.
Thanks for dropping by. All right. Let me finish this problem and we'll be done. This is the last one. It's a weird one, so I want to show it to you. X to the 8a, x to the 8a plus 7. So what have we learned about powers? Are those powers going to add or multiply? Add, because they're not outside parentheses, right? The only time they multiply is powers outside parentheses. So these guys, and you keep the base the same. Remember, we don't change the base. We just add the powers. So we're going to take 8a, and we're going to, let me just add them. So what's going to happen when you add 8a and 8a? 16a, and then you just keep the plus 7, and we're done. That's all there is to do in that one, is just add those two 8a's. It's weird looking, though, isn't it? I mean, it's really weird looking.
The A itself wouldn't have a component of 2 while we're adding, okay?
Yeah, we're just adding those. Yeah, right. Because if we're multiplying, that'd be a different deal. But we're adding those powers. Yeah, that's right. All right, let's do this. So we are done with that.